Dear students, today we are learning about dielectric medium. Dielectric medium means it is actually insulator. It is divided into two types. First one is polar dielectrics. In polar dielectric medium, every molecule is a dipole. For example, water. You know water's chemical formula is H2O. That means one point will act as OH minus, other point will act as OH plus. Means what? Here one charge is there, here one charge is there. Between them some separation is there. So negative charge, positive charge. And separation is there. Means what? It is electric dipole. And dipole moment P bar is negative to positive. In that way every molecule of the water is a dipole. So, and we can show symbol is this, arrow mark. So this tail represents negative charge, arrow represents positive charge. In that way every molecule of the dipole is dielectric medium is a dipole. But normally these dipoles are arranged randomly. That is why net dipole moment of the substance becomes zero because of random arrangement. Total dipole moment, because dipole moment is a vector quantity, so total dipole moment because of random arrangement, if you find vectorically, it will become zero. That's why on the whole the water amount which you have taken is not acting as a dipole. But when this is placed in some electric field, external electric field E, external electric field direction is left to right. In that we have placed this dielectric medium. Every dipole means that every molecule gets torque, experiences torque, and comes in field direction. They turn along field direction because of the torque, which is called equilibrium position. So because of that, chain-shaped arrangement will be seen. And because of chain-shaped arrangement, inside positive, negative get cancelled. So net charge inside will become zero. But only on the surfaces, here this surface consists of negative charges and this surface consists of positive charges. This accumulation of negative charges and positive charges on the surfaces of dielectric medium is called charge polarization. So these charges, negative charges and positive charges, are called charges due to polarization. This polarized charges, positive and negative. Because of that polarized charges, through the dielectric medium, one more electric field is formed. EP means what? Electric field E due to polarized charges, whose direction is from right to left, because right side here, right surface consists of positive charge, left surface consists of negative charge. So field direction should be from right to left. In that way, there is one more electric field EP whose direction is opposite to upper electric field E. External electric field E है ना, जिसका डायरेक्शन नेगेटिव टू पॉजिटिव, लेफ्ट टू राइट था. ये डाइलेक्ट्रिक मीडियम के कारण पोलराइज्ड चार्जेस के कारण जो इलेक्ट्रिक फील्ड बना है, इट्स डायरेक्शन इज फ्रॉम राइट टू लेफ्ट. So in that way there are two electric fields. But this polarized the electric field produced due to polarized charges is always less. Then for example, see here I have shown one diagram in which this is capacitor plate, this is also capacitor plate, and this is charged capacitor. Means what? This plate consists of positive charge and this plate consists of negative charge. And here positive charge density plus sigma, here minus sigma. So in that capacitor plates, between the capacitor plates there will be electric field. That electric field is E sigma by epsilon 0. And here one dielectric medium is placed, dielectric medium, then as soon as it is placed, it gets polarized. Means what? In its dipoles will arrange, molecules will arrange field direction. So due to which here polarized charges, here polarized charges. This surface is having positive charges due to polarization, and this surface has negative charges due to polarization. And polarization charges ka density I imagine as sigma p. So electric field due to polarization EP is sigma p by epsilon 0. So there are two electric fields. One electric field, applied field we can call. Means what? Electric field due to capacitor charges E is sigma by epsilon 0, because on the capacitor plates charge density is sigma. And another electric field due to polarized charges on the dielectric medium EP, that is sigma p by epsilon 0, where sigma p is polarized charge density. This field is in right to left. This field is from left to right. So net field how much? Net field E dash. If we check, E minus EP means what? Applied field minus field due to polarization. this equation we can write like this. Net field we can call sigma by epsilon, because if you don't observe this dielectric medium as polarized, simply we can treat between the two capacitor plates, the medium is filled with dielectric medium whose permittivity is epsilon. So the capacitor plates are having charges, the charge density is sigma. So medium is epsilon. So that's why net electric field should be sigma by epsilon. So without seeing polarization effect, if we see medium only has changed, then medium is now having permittivity epsilon and charge density and capacitor plate is sigma. That's why net electric field should be sigma by epsilon. So net electric field E dash replacement sigma by epsilon area. Next E means what? Applied field. Applied field means what? Field due to capacitor plates when vacuum is there. That is E, sigma by epsilon 0, minus field due to polarization EP, that is sigma P by epsilon 0, where sigma P is the polarized charges, charge density, polarized charge density. So this implies sigma P epsilon 0 is separated. From there, afterwards I wrote epsilon as K into epsilon 0, because epsilon is a permittivity which is equal to relative permittivity to permittivity of vacuum. So then I got sigma P is sigma into 1 minus 1 by K. Means what? This is one formula we got what for? To find out surface charge density due to polarization. Similarly, if you multiply area for both sides, then area into charge density will become charge. Means what? Polarized charge QP is equal to capacitor plates per charge Q into 1 minus 1 by K. In that way, two equations we got. One for polarized charge density, other is for polarized total charge. And net electric field, how much here? Sigma by epsilon. Means what? Sigma by epsilon, that is sigma by K epsilon 0. That is equal to 1 by K into E. Means what? Whenever a dielectric medium is placed in external field whose intensity is E, the net field becomes E dash, which is E by K. This is also very important equation. Next, there is a second type of dielectric medium, that is non-polar dielectric medium. Non-polar dielectric medium में no molecule is a dipole. Why? Because every molecule में पॉजिटिव चार्ज का ग्रेविटी पॉइंट और नेगेटिव चार्ज का ग्रेविटी पॉइंट एक ही जगह रहने से then it cannot act as a dipole. So no molecule is a dipole in case of non-polar dielectric medium. So next, when this material is placed in external electric field E, then the negative charge per gravity point will be attracted towards opposite field. This is external field. एक्सटर्नल फील्ड में ये डायरेक्टिक मीडियम को रखने से उसका मॉलिक्यूल जो डाइपोल नहीं था अभी डाइपोल बन जाता. क्यों बन जाएगा? बिकॉज नेगेटिव चार्ज है ना ऑपोजिट फील्ड को डिस्प्लेस होता, पॉजिटिव चार्ज अलोंग द फील्ड डिस्प्लेस होता. अब जब ग्रेविटी पॉइंट बीच के दोनों ग्रेविटी पॉइंट्स के बीच में सेपरेशन आ जाता, सेपरेशन आने से द मॉलिक्यूल इज एक्टिंग एज अ डाइपोल. So negative charge, positive charge, negative charge, positive charge. This molecule is also acting as a dipole. Negative charge, positive charge. Like that, automatically dipoles are arranged in chain shape. Due to which again you find here an accumulation of negative charge and here accumulation of positive charge, and remaining theory is same. What is that? Expression for polarization charge density is sigma into 1 minus 1 by K, and expression for total polarization charge QP is equal to Q into 1 minus 1 by K, and net electric field E dash is equal to E by K. These things are remaining same.